What is flux-core welding? Flux-core is an arc welding process that uses a tubular wire electrode with a flux-filled inner core. The American Welding Society calls this process Flux-Cored Arc Welding, or FCAW. All flux-core welding is done on equipment that is similar to, and sometimes identical to, the equipment used in MIG or gas metal arc welding. If you're not familiar with MIG welding, you might want to watch our What is MIG Welding video before continuing. But you should understand that flux-core welding has some important differences from MIG welding. In flux-core welding, the wire electrode is fed through a wire feed unit. Usually, this wire feeder requires knurled rollers that can grip the tubular wire without flattening or damaging it. As in MIG welding, an electric arc forms between this wire electrode and the workpiece. This arc heats both metals above their melting point. These metals mix together or coalesce and solidify to join the workpieces into a single piece. The metal in the parts to be joined is called the base metal, and the metal that comes from the melting wire electrode is called filler metal. Because the wire electrode melts as it's being used, flux-core is called a consumable electrode process. Flux-core welding always adds filler metal to the joint. The job of the flux inside the electrode depends on which type of flux-cored process it was designed for. You see, there are two main types of flux-core arc welding: self-shielded, known as FCAWS, and gas-shielded, known as FCAWG. You need to be sure you're using the wire in the way that it was designed to be used, because the chemistry behind these two processes is different. Flux-cored electrodes that are designed to be self-shielded contain a flux that completely protects the molten weld pool. The flux in these electrodes creates a protective cloud that prevents gases like nitrogen and oxygen from reacting with the hot metal. One advantage of the self-shielded flux-core process is that the added cost and inconvenience of gas shielding equipment is eliminated. Also, self-shielded electrodes are less sensitive to drafts and breezes that easily contaminate gas-shielded processes like MIG welding. This can be a real advantage in some applications. Electrodes designed to be gas-shielded rely on a secondary shielding gas to do the job of protecting the molten weld.